and to be the last presentation before the pause. It's on Python and Freshen to run BDDs. And
connector?
it's a Mac connector?
No.
Thanks. And it's presented by Jacek,
Yeah.
right?
It's Jacek Furmankiewicz, if you want a really long name. Okay. Okay. Let's see. Try. Alrighty. Better. Yeah. Okay, fine. So basically, we're going to talk about using Python BDD tools for testing of server applications across all different technologies. Maybe I'll talk first a little bit about what RadioPoint does, because that will help you understand the type of business problem we had to solve and how Python helped us solve it and save us a ton of money in the process. So basically, we have a SaaS platform. We offer a DHS service, which is a digital home service. So that's like premium support for non-technical users. And it installs preventative software on their PCs and very soon Android devices, other connected devices. And it's all white label. So it's all rebranded and reskinned for any of our business partners. So if any of your friends ever bought security from TELUS or Rogers or Bell, it's all our software, just totally rebranded. So it's branded for each of the partners. And as a company has evolved from one business area to another, it's acquired different applications along the way. So our core SaaS platform is all Java and Linux. We acquired a company from Boston that provides like the UI for call centers. It's all written ASP on Windows. And as of recently, the last year or so, we're aggressively doing web development for all our customer-facing sites in Django. So basically, we've got to mix the end-to-end solution for a typical customer will be some internal UI in ASP.NET, a big Linux server platform on Java, and the whole web front end running on Django. And that's, probably any company that's been around for a while has this type of mix of different technologies and has to deal with it. So when we started on our Java team, we adopted TDD and everything, and we're putting out all these Java JUnit tests, and everything comes out tested pretty stable. And our QA team basically caught up with that after a while, saying, we're testing all this stuff these guys put out, and most of it works well, and we just find edge cases. But we don't really know what they've tested, so we keep retesting the same stuff they've tested in code. And they came up to me to basically with a question saying, how can we know what the dev team has tested in your unit tests? And then we went with some different options. Okay, we could document what we put in our Java code, but that seemed like a useless exercise. I mean, that would be out of date 5 minutes after we code it. And basically, we started looking into different tools, and I had come across Ruby Cucumber at a certain point in time, and it sounded like a good idea. We didn't want to introduce Ruby into our mix because we have enough languages already. So we looked at the different tools that are available in the Python world, and there's basically 2 of them. So Python Freshen is a plugin for Nose that gives BDD functionality. Plus, there's a standalone tool in Python called also Lettuce that's developed by a bunch of guys from Italy. And we chose Freshen mostly because it's a plugin for Nose. It comes with a lot of nice reporting. It's, I think, a bit more scalable because it allows you to take code from different Python files when you're combining it for test cases, which I'll show you in a moment. And although Lettuce, I think, is a little bit more actively maintained at this point in time. But still, Freshen has worked pretty well for us. So BDD, behavior-driven development, is basically a testing framework where you write the unit tests in plain language. And behind every line that looks like just plain English, or you can write it in any language for that matter, there's a just a Python method that intercepts that, parses it via regex, extracts arguments, and basically functions as sort of a high-level macro. But it's written in plain English. So any QA person can look at the test case and see, okay, if I do a REST call to this URL, I expect HTTP code this, and I expect that. And if I do a SQL query against this database, I see it was updated. And they can understand. They see what you've coded as a dever, and they see what they need to add more test coverage. So basically, there usually consists of 2 core parts as a plain text feature file and a single or more Python file with the actual code behind it. So we'll see a quick example. And every feature file is basically a combination of these three keywords. When I do something, when something is set up, given something is set up, given some rows I insert in the database, given some system is running, we have a lot of mocks written in Flask that mock out other systems we talk to. When I do something, for example, when I send a SOAP call, or I send a REST call, or I update the database, then I expect something to happen, or something to come back with a particular result. So this is a typical example. Maybe it's a little bit small, but I'll go over here and I'll explain. So basically, this is a simple test for testing the put functionality on the REST service. So we have a REST service that, let's say, it expects a numeric integer value that you can pass in. And you want to test all the different invalid values you can pass to it, minus, negatives, decimals, alphanumerics, and you verify that every time the system rejects it and raises a 400. So you can, in this sounds, when you have 150 services like that, and each of them has 20 columns, all of this stuff and all this combination really adds up, and you have to code it all manually in code. It really takes a long time. So in BDD, you can write a regular scenario, which is just a set of steps, or a scenario outline, which is more like a template for the test, where here you have like keywords, and for every row in this, it takes whatever is in this table and plugs it as an argument into here. So this is actually 5 separate tests that get run. We're testing 5 different combinations of an invalid value, -1, 0, A, 3.6, and something outside of range. And here's a typical example of the Python code behind it. So we had a given, so given these providers, which is an entity we have in our database, we actually iterates through all the rows in the table and inserts a row in the database. When as user X, I send a post or put to this URL with these parameters, it extracts them via regex, creates an actual HTTP lib2 call to that URL, and saves the result of that in an instance variable. And then I expect HTTP code. It looks actually at the last value in that instance variable and says, okay, was the HTTP code 201? And if it was, the test passes. If it failed, it kicks it out. This is a very simple example. It can get a lot more complicated. So we've decided to see how far we can take this. And when we're redoing some of our portals in Django, we actually try to hook up Selenium to do automatic UI testing of this as well, which I'll show you later in the demo. So given I'm on the software supplier page, which is one of the pages in our portal, when I get to this page, when I enter this field in this value in this field, and I press save, I should see this message. So in this test, for example, we have 2 fields. It enters both of them. It gets a success message. If it misses one of them, then it gets a message saying this field is required. So you can automate UI testing as well. So Freshen doesn't come with any of the code to do this. You have to code yourself, but you can use it for anything, from SQL queries. One of the cool parts about Freshen, and here's actually the example with hooking it up to Selenium. But one of the cool parts about Freshen is that it allows multi-line comments in your test cases. So you can do, for example, testing of JSON responses. I mean, we have JSON responses that are 200 lines. If you had to code it by hand, okay, I get this field, and in row 3 of that entity, I get that value. I mean, you'd be coding forever. Instead, we plunk the whole JSON response here. When it's testing, it actually loads into a JSON document. It takes the content of the REST API, loads into JSON, and compares the 2 documents. And if they're off, you can even sort keys and everything to make sure that sorting issue doesn't get into play. I mean, this is a simple one, but we have JSON responses that are like, and we'll say we have billing invoices that span 12 months of transactional history. So the JSON is like, and yet you can test every single value in there to verify that it's the correct value. And another cool one is that with multi-line steps, you can also do complex SQL queries. So for example, here we have a SQL query, and it's supposed to return X amount of rows, and you can verify that we got this amount of rows and the exact values we were expecting from them. So the cool part, as I mentioned, is that our QA team wanted to know how could they know what we've tested and whether they could contribute. So nothing stops QA from writing these feature files themselves once they get a bit more familiar with it. So to get that to happen, we trained them on the basics of this. In order to push them to use it, we started submitting defects with BDD tests only. Like it says, here's the BDD file, here's the test that fixes this JIRA issue, and usually if there's a test file with multiple defects, we just put a tag on each defect so they can just run the test that were added for this defect. And we were easy with that at the beginning, but after a while, if there was a defect that came in QA and it doesn't have a BDD test to reproduce it, we'd kick it out. Say, unless I get a BDD, I'm not accepting this, and we throw it back to them. So we didn't do that in the first 2 or 3 months, but after a while, we basically started getting tough with that one. So the part that really made this happen is that we gave QA commit rights to our version control. So the folder where we have BDDs, they can commit and update just as much as we can. So when they get a Jira fix from us, they go there, look at the BDD file, the feature file, says, OK, but you guys are missing coverage for this test case. So they will add it and commit it right back. And in our build server, continuous integration server, they get added to the mailing list. So because they can break the build as much as we can with, let's say, an invalid test. So when the build gets broken, everyone gets notified. We looked at who committed the latest change, and we fire off a message. Well, the QA knows it's them. And they jump as much as we do whenever we get a build failed message. And both of us are responsible for fixing it. So like if you committed the BDD test, that was probably one of our QA guys. So if you commit a BDD test that breaks the build, it's your responsibility to fix it, regardless whether you are QA or dev. And so just to give you an idea of what productivity this gives us, literally in 1 year, we had 150 JUnit tests in Java. In 9 months, we got 2,200 unit tests in BDDs between dev and QA. And they're far more complex than most of our existing Java test cases. I haven't written a Java test case in like 9 months. I mean, some of our tests span like 100 lines of feature files. I do this, I do that, I wait for this, I call a Flask mock, it comes back, I query the database, I do something again, do a put, a delete. And it's all complex business test cases. We have a complex billing system with gazillion of weird edge cases, pre-off fails, pre-off successful, and you have to test all of that. And all of that is tested, and that's our latest output from our Hudson build system, 2,252 tests. It takes nearly an hour to run it, but because it's really complex. But that's the type of test coverage we need for our SaaS platform. Because every time this platform goes down or has a bug, usually my boss Alex has to go into a meeting with some VP from one of our US partners and listen to him howl over 15 minutes because the website got slow or screwed up somebody's invoice. So we need this type of testing coverage. And of course, before we go into the demo, we are hiring a lot of Django developers because all of our solutions team and all of our web development now is in Django. So I'll mention that. And let me show you a quick demo. So we have here we have Selenium running in the background. I'm going to basically fire off Freshen running our automated portal unit test. It should bring up slowly Firefox, hopefully. There it is. And that's a simple portal we have, and it's running all automated, driven by Selenium. So while you get hypnotized by these, you can ask me some questions.
Use the Selenium driver, where you can code Selenium with Python.
Yeah. So basically, we have the Java Selenium server running in the background, and from the Freshen code, we just use the Selenium driver to code all of it.
Is it local code?
This one, yeah, but the way it works is our dev team has everything localhost, so we have MySQL, Oracle, Java, and Python all running on our dev stations, and QA actually, but everything is soft-coded in the settings PY file. So in the QA environment, instead of, for example, using mocks, they actually point at the real systems. So they override the settings file, and they run it across real servers on separate machines. So they might have Oracle on one machine, MySQL on another, the Java platform on another, and some old Perl system we have to speak to on another IP. And they'll set it to these real systems and rerun the same unit tests and verify it works just as well against the mocks as it does in real production. So this.
Sorry, your QA staff, do they read the test? Like, I guess they have to read the test.
They read the feature files.
How much training have you done to do that? Has it been hard?
We were lucky because we have 1 or 2 guys on the QA team that are fairly technical. Like, they're not afraid of opening up Vim and looking into a shell script or something like that. So there's 1 or 2 guys that really drove the adoption of this. And once they got familiar, then they trained the rest of the team. But I mean, as you've seen some of those steps, when as user X, I do a put to this URL with these parameters, it doesn't require super, as long as you understand REST, you can figure it out. Or when, as user X, I do a SQL query and I expect these values, as long as you understand SQL. And most of these guys know our database structure, so they would know which tables to query to figure out that the database has been updated accordingly. So they were doing the exact same thing. They were just doing it in their own, proprietary testing tool. I think it was Mercury Test Runner, one of these guys. And as I said, they didn't know what we had tested, so they had to retest the same basic stuff all over again.
Did you find it difficult to map BDD syntax to Python syntax?
Not really, because if you've seen from the example, it's really just English text, and you just put regex groups into what you want to extract. I think it would be good for Freshen to ship with a default file for some basic stuff, like I execute SQL query, I put an X call, a post call to this URL. But it didn't take too long. It grew from like a small set of steps. Every time we got some more complex requirements, grew more and more. Like for example, I think now we have 4 or 5 separate steps file, one with the common stuff, and all the other ones are with customized calls for talking to other systems. Like we have a billing system integration with a company called Zora. So they have the whole billing system generating invoices. They have this huge complex SOAP API. And because this test environment they gave us was incredibly slow, we basically mocked out their whole system in ZSI. Their entire SOAP, and actually our SOAP works, with some of their SOAP doesn't. That was one of the problems. We found out that our mocked actually worked because we implemented their specs as their docs say, and when we ran it against their system, it actually failed. So that was a surprise. And so we can do really complex mocks. So the simple mocks we use Flask, and for the SOAP mocks we use ZSI.
How much time do you spend writing mocks?
Very little, because we don't have that many systems. And what we've done is that at the beginning, we implemented our partners' APIs. And as we got bigger, we sort of enforced the standard REST API that we enforce. So basically, say, you have to implement it. So we do a generic mock that just knows how to handle our API, and that's it. And that's it. So.
Okay. You're still using unit tests?
Well, the old ones that were written in Java, they're still there. Occasionally, when I get tired of it, I just rewrite one of them in BDD, just if there's like a bug in it or something that pops up, and screw it, and I'll just write a BDD file from scratch to replace it. But as I said, we haven't written a new one in like 9 months. So when we run it in the Java system, we run it in Maven, which is this popular Java build system. So it first runs any existing Java unit tests, and then during the test run, it shells out and runs Freshen. I wrote a simple Maven plugin that knows how to handle Freshen, so if it gets an error from Freshen, it aborts the whole Java build and things like that.
But you're still starting with your test first, and then everything after that?
Depends on how do you have the specs in advance, or sometimes it gets a little bit. For some of the simpler ones, yeah, it's easy to do the tests in advance. Some of the complex ones, we're sometimes, we're getting specs as we're coding. Oh no, this is wrong. This is not the way the customer wants it. So sometimes it's easy just to code it first with some basic tests and then add them later. It's really, the reality is that we don't always get like a nice clean of specs. Here's what you have to do, and it doesn't change. Sometimes it changes every 2 days. So that's the reality of development.
Do you look at the robot framework at all?
No.
Okay. I was just introduced to that last week. It's an acceptance of BDD.
Mm-hmm.
So I was just wondering if you have any opinions or.
We've really, I think BDD originally was meant for more like specs. We've really stretched it because there's nothing in it that limits you to specs. We've stretched it to pretty much like pseudocode. That's literally like macros, but it serves our purpose. And as I said, going from 150 unit test to over 2,000 in the space of 9 months with, I think, and it was really slow in the beginning, but now that our QA team has gotten familiar with it, they add like 100 unit tests every 1 or 2 weeks. This 2,200 was 1,500 just about 2 months ago. So it's rising exponentially. And they're more and more complicated unit tests as they get familiar with them. Like I've seen some of the big ones, they're like 200 lines of feature steps in one test case.
Okay.
So.
What's your test execution time increase also?
Oh yeah, but.
And where if somebody breaks the tests, right? Nobody else can really commit or work. Fix this stuff.
Not really, because when Hudson breaks, which it does, so everyone gets an email and jumps on it and see what to fix. It takes us about an hour to run right now the main unit tests, which is when I ask for a quad-core machine. I'm going to be reinstalling Hudson on that one. And we probably might get a cluster of them, 2 or 3, because we have 5 different apps. So there's one really, really big one, the one that has 2,500 unit tests, and the other ones have maybe 400 or 500 tests each. So we might run the smaller apps on one server, the huge one on the standalone server. Plus we run all the integration test runs for our maintenance branches for all the releases to ensure that they don't get broken, yada, yada, yada. Sometimes we have to do emergency fixes on a maintenance branch that's in production, so we want to run the full, 3,000 unit tests on the branch as well before we put it into production. Because as I tell you, when we have a public downtime, it gets really public, and it's not like it doesn't go under the radar. We have to sit in a room with our partners, because this is their public facing. It doesn't say radial point on it. It says Rogers, or it says Windstream, or it says Telos. So it's their name that is being, that's not getting good reputation, and we have to explain ourselves. So we're really serious about testing. Like, we don't release stuff into production unless it's tested, and that's not like a, just stereotype, but it's true because we get to pay for it otherwise. Like, downtime for us and buggy software is just not an option.
So what happens when you found an error? Like, it's finished and there's no notification?
Oh, sorry. Well, here. Here's your notifications. Yeah, I got some. This is an old. This is one that has some bugs in it. So, for example, you get here failed errors 37, fails 1. This is on an old project that we haven't maintained in a while, so it's a little bit out of stale. So you get. Yeah, well, basically, it runs all in Hudson. So when Hudson fails, it fires up an email to the whole development team and the whole QA team. And everyone jumps and tries to figure out who's to blame.
So is it automated? Like it runs every hour?
Yeah, well, it runs on every commit.
Every commit?
Yeah, but that's standard Hudson,
You also get the commits, the person who commits.
Oh, yeah. Well, sometimes you get like 20 commits. Then you gotta like, okay, who touched that file? And then you gotta start digging. And sometimes you might change a code that seems totally unrelated, but let's say it changes the format of some JSON response, and it might break some BDD somewhere else altogether that you didn't expect, and then you have to do some digging to figure out what actually changed. So.
And you run only in Firefox or different browsers?
This is the Selenium test, which is sort of on our, which we're just really experimenting with now. Most of our stuff is for a SaaS platform, which is a pure API. So it doesn't